Hello, and this is the second video about linked list. In the first video we were looking graphically how this looks like, and this was how it looked like. And in this video we are going to write some code actually about this whole thing. And let's start here. The first thing we need is this node structure, which is here. So this one here, this integer here, contains the data, the value of the node actually, which was in the last video we were using this one, these values. For example, if we want to have a list which have three values 5, 2 and 17, they would go to here. So this value contains the value of the elements, and this is the pointer to the next node, and it's a pointer to a node, so the same type as here. The first thing we need to do here is that we need to create this root node, which is gonna point to the first element of the list always, and it should always remain there so that we can get access to the whole list at any time. Then we need this current node that we can travel to the next node using this current node, this pointer to a node. So we are using this current to travel to the next node and to the third node and fourth node and so on, because this root remains in one position, so it's good to have this pointer. We can use it to travel from node to node, and then we can get access to the data using that. And then I will create one helper pointer here, new node. So whenever I create a new node, I will set this one point to that new node first, before we linked it to the list. As we remember from the last video, always first thing we did is that we just created a node which was not linked yet to a list. So that's what happens here, that we will create a node and we will set this one point to that new node, to the memory location of the new node. Alright, let's start this coding. I will copy. I've done this already here, so I'm just copying here, but I'm going line by line, so it's easier to see what's happening here. Right, so first thing we need to do here is that we need to create a new node, simple as that. As we remember from the picture, we created a new node. When I was talking here, I was always copying from here like this. I was copying one node. I said that okay, let's create a node like this. So this is what we are doing here. We are creating that this new node creates a new node, and it returns the address of that new node. So we will save that address to this pointer, just to save it somewhere, otherwise nobody knows where it is. I will take that out. The next thing we need to do is that we need to fill up this node. Like in the last video, I said that we will always fill up the values first. We can fill up the values first and then link the node to the list. So that's what I'm doing here. I'm first setting this value to 5, because we wanted the first element to have the value 5, and then next I'm just setting this the point to nil, because this node currently does not have any other node where it's pointing to, so we are setting it to nil, meaning that it's not pointing to any other node. And then let's see what happens next here. And here, because this current node should always point to the current node we are dealing with, that's why I'm setting here straight away, because at the moment, in the beginning, current node obviously points to the first node. So this is the first node, so we are setting the current node point to the first node, and the root also needs to point to the first node, and it will remain there to the rest of this code. So this is where we set the root node, and its value will never be changed in this code. The current is also, so current and root both are pointing to the same first node at the moment. So that's it. And because if we remember from here, this next, so we have this situation now here. So this next needs to have a nil value, so that we know that this is the last node of the whole list. But we already have it here because I set it here to nil, so this all works now nicely. So next we can add the second node. Let's do it as well, step by step. Again, we will create a new node, and we can, this temporary new node pointer here, we can set it now to point to this new node. And then we will fill up, like it's very much the same what we did in the first node. So we do the same thing here. We are first setting the next to nil, because this node, this is a new node, obviously it doesn't point to anywhere at the moment. So we will set it to nil, and then the value, we will set the value to 17. The value of the second element will be 17. And now what we need to do now, what am I doing here now? Well, if we look at here the picture, current is currently pointing to this first node, because we set the current here to point to the first node. So current is pointing to this node. So, and we are adding this second node here. So, and at the moment, because at the moment before we added the second node, this was nil here. But now this should point to the second node, and that's what I'm doing here. I'm saying that the current, which is currently pointing to the first node, the current next, which is this one, set to point to the new node, which is this node here, which is the second new node, is the second node here at the moment. So now this one is done here, and then we are updating the current node, because now we are dealing with, now we are at the moment, we are now here. We are now jumping from first node to the second node. So the current, we are updating the current to point to the second node now. So current set to this second node. And that's it. And everything is perfect now here, and so we can finish this and do the last node, which will be exactly actually the same as the second node. If we look at it, and oops, this was not the second node. I mean third node. This is the third node. So here we go. And as we can see, it's exactly the same thing what we are doing here actually. The second, first node. Just that these values needs to be what we want. At the moment they are not. We wanted 5, 2 and 17. So 5, this needs to be 2, and this is 17. So as we can see, the second node and third node, it's exactly really the same code here. The only difference is that this value is different here. Otherwise they are identical because it's the same logic we are using. So now we have 3 nodes here, and now we can, for example, let's say that we just want to print the values now. We have created 3 nodes and we just want to now print these values of each element. So how would we print the whole list? And here is the code to do that. Print all values, travel from the first to the last. Okay, so we can use the current. We have done with this current now here. We don't need it anymore here. It's just a temporary variable anyway. We just use it to create new elements. And so let's initialize this current now to the root. So we will go to the first element. We will go to the first element, and it's here. So we will go to the root, and then we go to root, and we will print this value, and then via this next we are going to the second item and we will print this value, and via this next we can go to the third item and then we can print the value. And here, because we can see that next is nil, we know that now we need to stop. That's the logic here. So let's start. So we set current to the root, and then we can print current value. Is the current value, and then we can set current set to the current next. Well, what is current next? Current next is this one, and the value of this next is the address of the second node. So now current here will be the second, pointing to the second node, and then we are saying that current value, it's this value here now. And then we will do the same thing again. We will say that the new current will be the old current, which was this current, its next value, which is this one. This value is the address of this one now. So that's why this current next is the address of the third node. So now current is pointing to the third item, and then when we say current value, we will get the third node's value. Okay, and if I compile this program, and I will show that it works, and run, and there we go. We have the 5, 2, and 17. Okay. As we can see, there is a lot of repetition here. All of this is really a repetition here. We are repeating. And let's say that we have 20 values. We will not really like to do like this, just copy this code. It will be a long code. So we want to use a while loop here instead. So let's take out this one. Let's take out this one and do it a better way, which would be using a while loop here. So using a while loop, we will travel the whole. So it starts the same as here. So we're setting current to the root, and then we are saying that while current, the value of current is not nil pointer, then we will repeat this section. First we will print the value of the current, and at the beginning it's the root node's value. In the first round it's a root node's value, and then we will update, like here, we will update the current to be the address of the next node, because the current next always contains the address of the next node. So this one keeps going from a node to another node. And lastly, when we are dealing with the number 3 here, this one, when we are here, we will first print the current value, which is this 17 here, and then we will set current is this current next, which is this nil pointer, so that's why nil goes here and this loop ends. And let's test this quickly. And there you go, the same result here. Okay, thank you for watching. In the next video we will be making this code a little bit more better, and we will create functions to do this same thing. Okay, thank you for watching.